welcome everyone to this new edition or new issue of the webinars that we are preparing this year for you. This is part of a series that of webinars that we are putting together to showcase the use of the European Weather Cloud, uh, giving some particular examples on how to use those resources, and maybe inspiring you on doing the same thing or similar things using your own resources. So today I'm going to talk about using Jupyter on the European Weather Cloud to interact with ECMWF data sets in particular, but you could extrapolate this to other data sets, or even get some ideas on how to do certain operations in the cloud to and apply it to your own workflows. My name is Xavier Abellan. I am working at ECMWF as part of the user services, and we take care of advising and helping people on board our computing and software services and data services, and part of it is also helping everyone to get on board the European Weather Cloud. So that's why we are here today as well. Before we get into the business, let's remind everyone what we're talking about when we say European Weather Cloud. For those of you, I'm sure everyone has heard this project. If you're here, it's because you know more or less what this is about. But this, for those who are not sure what it is, mainly what we're trying to do here is to provide a cloud-based collaboration platform for the community, for the meteorological community, in Europe, for application development and operations. So anyone from member states can jump on board to do some research, to fulfill their official duties. It's in a sense a community cloud. We started operations last year in September, but before that we had been running in pilot mode for a few years, and during that journey we onboarded a number of different use cases, a wide variety of on a wide variety of topics. So we got a lot of feedback and a lot of knowledge on how to operate this service. So very quickly, what are the main points of the European Weather Cloud? Well, the main thing is to get you guys as close to the data as possible. So bring the computation, all the things that you need to do with the data as close as possible to the data sources themselves. So we are offering some virtual infrastructure on both sides, EUMETSAT and ECMWF, so that you can access those services, push or pull, in a very fast and robust way. So typically, if you want to do something like this, you would get a so-called tenancy, an isolated environment with your virtual resources, from which you will be able to access, for example, Mars, ECPDS, CDS, if you are after ECMWF data, or if you are more interested in satellite data, you could also be running on the EUMETSAT side of the cloud and access the EUMETCAST terrestrial and other data services there. You will all see this virtual infrastructure, manage it through something called Morpheus, which is a cloud orchestrator that will allow you to manage, provision all those virtual resources in your tenancies. If you don't have a tenancy yet, and you after this workshop you feel that you want to give it a go, this is how you can ask or get access to it. Because the access is managed by the every member state, you will need to get in touch with the authorizing officer or computing representative in the country to request access to the European Weather Cloud. And if they will authorize this, then a request will be put forward to us, the European Weather Cloud support, and we will create the tenancy for you and guide you in your first steps. You can also try and get in touch with us first with your request, but then in that case, we will be the ones getting in touch with the computing representative, the authorizing officer, to make sure that he is happy or they are happy to get you on board. And then if all is good, then we will give you all the access and the information you need to get ongoing. And lastly, I would also like to remind everyone that we have this community chat open to everyone here. You can join at chat.europeanweather.cloud, and here you will find all your colleagues and from all over Europe that work on the European Weather Cloud, and you can share experiences, thoughts, questions. We are also there from the support team, so we might be able to also contribute to the discussion. So feel free to use that chat platform either now during the workshop or later after the workshop to ask questions or to, well, put your ideas there and share them with the community. So back to business, today's business. What we're going to do here is a bit of baking. Okay, so we are trying to bake a reproducible cake. We want to follow some recipe that we can use again and again to provide us with some resources on the cloud that we can use for our needs. So we are going to structure this in three parts. The first one is going to be the preparation. So we are going to gather all the ingredients. We want to see what we need in order to do what we want to do. Second bit will be the actual process of baking the cake. We will go through the recipe and we will walk step by step through the whole process. And once we have everything ready, we will try to enjoy the data and visualization cake through Jupyter, accessing all the Mars and different data sources. So let's start with the ingredients. What we're going to need today, we're going to need one European Weather Cloud instance. You will also need to have a Mars and CDS account if you want to access those services. We will be also using a season conda environment, and we'll add a pinch of Jupyter on top. We will use a few cubes of ECMWF software to give it a bit of flavor, and a dash of Git and a teaspoon of Ansible for the automation of the whole process. And let me remind everyone a few bits and pieces if you're not familiar with the different aspects. I won't give anything for granted. So even if you don't know anything about our data services or the automation tools, I will try to at least give you a bit of an introduction to them. So in terms of data sources, we are going to be using Mars, which is nothing to do with a planet. I know we're talking about Jupyter and Mars, but we're down on Earth, even if we're on the cloud, right? So meteorological archival and retrieval system, that's Mars. It's a huge database of meteorological data. We host it in our data center in Bologna, and we are very, very close to 1 exabyte of data stored in those tape libraries. We are growing at about 300 terabytes every day. If you are working at ECMWF from any ECMWF platform, you will have direct access to that archive. That is from the HPC facility, for example, or as well if you are on the European Weather Cloud at ECMWF. If you are not at ECMWF, you can also access over the internet via an API, but of course the access won't be as fast. But Mars, the downside to this is that Mars has many data sets, or most data sets have access restricted. So you need to have a specific access and privileges to access, for example, all the operational forecasts. The other data repository that we're going to use today is the CDS, or the Climate or Atmosphere Data Store. This is part of the Copernicus service that we operate at ECMWF. We operate both the climate change service and the atmosphere monitoring service. And we, through this data store, we put into the community available access to a lot of different data sets, which might be also distributed. We have part of them in our facilities, in our data center, and part of them are elsewhere. And this is the home to a very popular data set you may have heard about, like the ERA5 data set, the reanalysis data set, that is free, it's open, and you can access even if you don't have any special grants from anywhere or anyone. So the only thing you need to do is to self-register into the data store, and then you're good to go. Good news is that we are migrating now our data store to the new backend infrastructure, which happens to be the same one that we run the European Weather Cloud on. So you can't get closer to the data than this if you are on the European Weather Cloud. You will typically access the data sets over an API. You can also access through the web portal, but typically if you are using your programs, you would access it through an API over the internet. We will be also leveraging the Python and Python ecosystem. So, well, if you don't know Python, it's a high-level programming language, but it's very popular in the scientific community and data science area, because it's got a lot of ready-made additional libraries and modules that you can use and you can easily install and then benefit from them. We will be using Conda as well for the installation of all those Python packages and other dependencies that we're going to need, and all of that we will be accessing through Jupyter. Jupyter, again, not the planet. This is the, you may have heard about the Jupyter notebooks. Those notebooks are very popular, again, amongst data scientists and in science in general, because they allow for easy share and reproducibility of scientific code. You can combine in the same document code, documentation, visualization, and it's then very easy to use in environments like this, for example, on training, or if you are quickly doing some research or some analysis. We will be running those Jupyter notebooks in something called Jupyter Hub, which we will install as well. And this will basically be the interface, a web portal in a way, that will allow us to interact with those notebooks in a very easy and convenient way. On top of that Python and software stack, we will also add the ECMWF software stack. We will install a few packages of our own so that we can make sure that we can access the data, we can decode the data, manipulate it, compute whatever we want to compute, and even plot it. So tools like EC codes for the grep decoding, which is going to be the format that we produce and distribute the data. METView, which is also the meteorological workstation that has also some Python bindings that will allow you to access all the capabilities through the notebooks directly, and the new package that we are developing at ECMWF, also to as an integrated way to retrieve, decode, compute, and plot data, which is called EarthKit. For the automation part, we are going to use Ansible. For those of you not familiar with Ansible, this is a very common tool in the IT world for automating processes, configuration, deployment of applications in the cloud environments. It's basically following these principles of infrastructure as code. So what you are going to do is to define in something called playbook what you want the automation to do, and then it will when you execute that playbook, it will go through every task and we'll make sure that the final state, meets what you specified in that playbook. Because it's code, we are gonna use Git as well to host it and to keep track of all the changes and manage it. Git, for those of you who haven't used it, is a distributed version control system, very popular nowadays as well. And it will allow us to do all the version control and make sure that the code is secure, and we can always revert or make any changes in a robust way. And we have to put that Git somewhere, that Git repository. And for this example, we are using GitHub, which is the platform where you can create, store, manage Git repositories. So we're going to make use of that too to host our Git repository. So baking plan. We've gone through some of the ingredients, but we also have to make some decisions here. We said we want to install a Jupyter environment on the European Weather Cloud to access our data sources. So first decision is how to install Jupyter itself. There are many ways of doing the same thing, especially on the cloud. So for example, there's this project about 02 Jupyter Hub, which allows you to deploy Jupyter Hub on a Kubernetes environment, aimed for bigger installations of Jupyter, catering for many users. Not the case here, and probably too complex to show in a 1-hour webinar. So we will not use that one. There's on the other end of the spectrum, there's the leadless Jupyter Hub, which is also an attempt by Jupyter, the Jupyter community, to have a very simple deployment, typically on a single VM virtual machine, for small deployments for a few users. This would have been an option as well today, but we are going to use a custom installation in this case, because what I wanted to show you today is not only Jupyter itself, but how to automate the deployment of an application. And I'm just taking Jupyter as an example. For the automation, you could also as well do everything in a shell script, so that is possible. But we are, as I said, going to be using Ansible, which will give us a lot more flexibility and robustness to the process, because we will be confident that we can rerun the automation safely without really spoiling the cake. And the last consideration that we have to make here is how we are going to make the service available. As I said, Jupyter is a web service, a web application. So you would typically access it through a browser. Now we could expose that service through a HTTP, plain HTTP, but that's not great, especially not secure, especially if you are exposing this to the internet. So I'm not even considering that option. One option would be, for example, to use HTTP over SSH. So that is very secure, because it requires you to create an SSH connection and establish a tunnel so that you can access the HTTP through that tunnel. But it's a bit cumbersome to set up and not very convenient. So we are going to go for the HTTPS option. So we are going to expose directly HTTPS service to the internet, so we can access from anywhere. Next thing that we're going to do is to have a bit of an overview of the Git repository that I mentioned, where we have all the automation, Ansible automation. I'll go through those different elements on how to set things up, and later we will configure all the integration with our cloud orchestrator Morpheus, which will allow us to provision the instance and execute that workflow on top, so we can have everything up and running in no time. So let's go to live demo. What can possibly go wrong here? So let's move on to my browser, this is GitHub. This is the URL with the demo repo that I'm going to use today. It's open, so you can also go there and have a look yourself if you want to, and use it if you feel like it as well. So we're going to start with the Ansible, and as I mentioned, in Ansible we talk about playbooks. We have one playbook here. This is a playbook, very simple. You would typically have in the playbook a sequence of actions or tasks that you want the playbook to execute. In this case, to simplify and to make it more modular, I've encapsulated all those tasks and actions in so-called roles, Ansible roles, which will allow me to, well, in the future, reuse some of those roles in different playbooks if I want to. So basically, I have three roles in the playbook. One to make sure my instance is up to date. One to install Mars if it's not installed, and the last one to install Jupyter itself. So let's have a look at the roles. I won't go through the update or the Mars ones. You can also choose to provision. When you provision an instance, you can choose the data layouts, and they will already come with Mars. But I just want to make sure that if you run this playbook on an instance that hasn't got Mars installed, you can get it there too. So let's focus on just the Jupyter bits today. And if we go to the tasks of this role, we can see the scheme here. Basically 4 parts. We will use, as I mentioned, Conda to provide our software stack for this example. So first thing will be to install Conda. Then we will install Jupyter as part of that Conda environment. We will install and configure certbot, and this is basically to manage the SSL certificates, the TLS certificates that we're going to use for our HTTPS connection. And lastly, we will set up the Jupyter service so that then we can start using it. In terms of the, I won't go through the details of all the different tasks, but this is how a typical Ansible playbook would look like, or set of tasks. You just use some of the predefined functions in Ansible, so you can make sure that things are in place, and you can run the installer in this case, and ensure that that is loaded in the profile, etc. So next thing would be to install Jupyter itself as part of a Conda environment, and this is also an important bit. So this is going to be creating the environment itself, which I have defined in a YAML file here. With Conda, you can create so-called environments, Conda environments, which you can export like I've done here, and you have a list of requirements in the environment itself. And as you can see here, I'm installing things like Python, Jupyter, a number of dependencies for computation, NumPy, Dask, SciPy, etc., for plotting, for accessing data like NetCDF, and as well, if you go towards the end, a number of ECMWF packages that we're going to use as well, like NetView, CDS, and EarthKit. Another aspect that I wanted to highlight in terms of the automation of the HTTPS setup, we will need to create and to maintain those HTTPS certificates for our HTTPS support. For that, we are going to be using, in this example, something called Let's Encrypt and certbot. Let's Encrypt is a service that you can use free of charge online to generate short-lived HTTPS valid certificates that will be accepted by any browser nowadays. And but those certificates have a very short life. So you need something that takes care of creating those certificates in the first place and making sure that they are up to date and renewed when needed. And that's the certbot task. So we will be installing certbot here and setting it up so that then it can correctly manage those certificates. And I'm basically leveraging two things here to make that happen. First one is using the DNS service that we have recently made available to everyone on the European Water Cloud. So when you provision an instance, you will automatically get a DNS record for that instance that you can then use. And I'm getting it through this hostname -f running on the actual host. That will give me the fully qualified domain name of my instance. And I will be also using Morpheus and Morpheus integration in this case to get the email address that I need to register onto the Let's Encrypt service. When you create a certificate in Let's Encrypt, you have to pass an email address of the person behind that certificate. So what I'm going to do is to use that variable coming from Morpheus itself. So when we integrate this playbook into Morpheus, as part of the integration, you can then access some Morpheus variables. And in this case, we will be using the user's email in Morpheus to pass on to the Let's Encrypt for creation. If you run this playbook outside Morpheus, which it is possible, then you will have to explicitly define that variable. And lastly, the last task in this role would be to make sure that we have set up Jupyter properly. So we will configure Jupyter to listen on to the HTTPS. As I mentioned, make sure that the certificates are in place and that Jupyter knows where to find them. And just for convenience, I'm going to also redirect the HTTP 80 port to HTTPS. So then if you access by accident the HTTPS on the browser, it automatically redirects to the HTTPS service. And as you can see, last thing to do is to make sure that the Jupyter Hub service is running in the machine and print our URL there so we can access. So this is the automation. Next bit would be to show you how to do this integration in Morpheus. Now, because the process takes a bit of time, and we don't want to just sit and wait while the instance is set up, I already did that and I recorded myself, so you can now I can now show you without having to wait so long. So let's move on. So I'm now in the Morpheus in my tenant, and then I'm going to go to library automation, and I'm going to configure the integration with Git. So I'm going to add an Ansible integration, and here I will give it a name so that I can remember. The URL itself of the repo that I just showed you earlier, the default branch in this case main, and where to find the playbooks themselves, the roles, and other bits and pieces. And you can also define a number of different options. You can instruct to use Ansible Galaxy if you need it. You can enable the agent command bus if your instance hasn't got access, direct access from internet. And once you're happy, then click save, and there you go. We've got our integration ready. Next thing is to create a task, and we will map one of the playbook, our playbook, to a Morpheus task. We give it a name. You can also put some labels if you want to, and the type is going to be an Ansible playbook. And when I select this, you can see that automatically Morpheus picks up my Git integration, And then the only thing I need to do here is to just say which playbook I want to run as a task. If you want to allow users or yourself to customize the Ansible run with extra options on at runtime, you can also click that option. Next thing is to create a workflow, and we're going to create a provisioning workflow. A workflow, if you remember from previous webinars, this is a collection of tasks in Morpheus. In this case, we're going to have just one task in this workflow, which is the one from our Jupyter integration in Ansible, and I'm going to use the post-provision stage to run that task. Essentially, because we need to have the DNS name present before we can run the automation, so that the certificate creation works. Right, so we've got everything ready. Now we can start creating our instance that we're going to use for the webinar. I'm going to go for an Ubuntu. You can choose Rocky if you want to. Give it a name. I'll call it webinar. You can also select a number of metadata options, labels, etc. But the important bit here is to pick up the right size of your instance. I'm going to go for an 4 CPU, 8 gigabytes of RAM to make sure that Mars can deal with my data. Because I want this to be exposed to the internet, I will choose the external internet and make sure that I enable the HTTP access through the security group. I could have used a floating IP as well, so that also works, but this is just a bit quicker. And here's the key. We are going to tell Morpheus to run our workflow, install Jupyter Hub. We're not going to pass any extra options here. And here you can also define if you want backups or something else. But by doing this, we will make sure that our workflow will run while we create the instance. So at the end of it, we're going to have our instance with everything set up and ready to go. This process, as I mentioned, takes a bit of time. So what you can do in the meantime, you can also click on the instance itself and have a look at the process. You can go into the history tab and see what's going on. So if you click on the arrow down below, you'll see that there's all the action here, and if you expand that, you will see the output of the Ansible tasks. So if you want more detail, you can click on the eye, and you will see that the thing is progressing, and you can see all the output here. You can see it's been doing all the update, the installation of Conda, installation of Mars, and once it's done, we should see this line at the bottom that the playbook is complete, and we can see all the details here. Everything went fine, and at the bottom I included this task to print the URL itself of the service, so I can copy and paste it on a new tab, and my Jupyter will be ready to go. I can log in here with my Morpheus setup, whatever user I have set up as my default user in my instances, and the Jupyter will be spawned for me, and this is how it looks like. This is a Jupyter Lab interface, which will allow me to create notebooks from here. On the left-hand side, a file browser. I can run a terminal if I want to on the instance. I can run an interactive Python console or any other console for other languages if you install those in your software stack. And we will also be leveraging the Git plugin to pull some Git repo as well. So this is it. So we've got our instance running. Now let's see if we move on to the next. Let's go to the next phase of the webinar, which is actually eating the cake. So using our instance of Jupyter to do some real work. So this is what we're going to do. We're going to connect to our Jupyter. We will fetch the Git repository and configure all our credentials, and then run some notebooks to show you how to access different data sets, and to do some end-to-end retrieve process plot with MetView and EarthKit. So let's see if I can find my Jupyter. Here you go. So this is my Jupyter instance. Now, first thing we need to do is to clone the repository where we have the notebooks. So let's go to the Jupyter demo, copy the URL, and download the repository. And this is it. I could have done it with the command line, but this is fancier. And here is my repo. Now we are going to focus on the notebooks themselves. I've got 4 notebooks here. So let's start with the first one. For those of you who've never seen a Jupyter notebook, this is how it looks like. We have a bit of text and some cells to execute some code. So for this example, I'm going to do a basic download of ECMWF data, but in this case, ECMWF open data. So this is data that can be accessed freely from anywhere by anyone without even having any account at ECMWF. This data is, if you're curious, you can click here, is released on the CC4 BY license, and it's making available products 1 hour after the real schedule at a 0.25 degree resolution. And we keep around 4 days of data in that repository. We have this ECMWF Open Data Python client that we can use to get that data. So typically you would install it through a pip. We don't need it because in this case, because it's already installed as part of our Conda environment. So let's start running those cells. I'm going to be getting some parameters, 2 meter temperature, mean sea level pressure, and UMV components of wind at 10 meters at different steps. This is the actual request. So I'm retrieving the data. It's all done. I'm also going to retrieve an extra file here for the analysis field. And here we have both files that you see they are popping here. We can also see them here. They've been created now. And we can also use the grip tools as part of the EC codes library on the command line to inspect and have a quick look at the grip files themselves. So as you can see, we have those 2 files, and we have the fields that I mentioned, the temperature and the winds and the mean sea level pressure on the different steps. You can also use the tools to do things like get some statistics about the values inside those grip messages. You can use tools like grip count to have a quick look at how many fields we have in each file. And we can even use grip dump to have a complete dump of all the metadata in the file, in the grip message, And we can also use the grip get data command line tool to actually get all the data. I'm not displaying the whole thing because it's pretty long. This is a global field, so I'm just displaying the top level fields. Now, what I did here with the grip tools, you can do from the command line as well. I just did it from the Jupyter because it's easier. So you can do this from anywhere, as I said. Let's go to the next notebook, which is doing a similar thing, but now using direct access to Mars using the native Mars client. And for this, you do need to have an account at ECMWF with the right privileges to access the archive. And the way you can configure it, and this is something that we have improved in the last few weeks, is to use the ECMWF key, API key, to do this. If you go to the this page, you will get to, and you log in as with your ECMWF account, you'll get to a page where you have your credentials. Now I've blurred mine, but you can then copy those credentials and paste them here and write them in a file called .ecmwf API RC. So you could do it like this. I'm not going to do it because I've already done it myself. You can run this, and then you will get those credentials configured. To test that this works, I'm going to run a very simple Mars request, and this is running now, and it's all done, and it's created my first .grip file. In this case, because I didn't pass any particular elements to my request, Mars will fill in the gaps with some defaults. I'm getting some analysis data on different pressure levels for yesterday's 12 run. As you can see, this has accessed our field database on the HPC where the data has been produced and retrieved it very quickly. This is our file, which has been created now. And this is a quick inspection of the file with gripls to make sure that we've got everything. Now, if you want to have a more realistic example, I have a couple here. You would typically go to the Mars catalog and then browse through the archive the data that you want to retrieve. And once you get to the last page, you will get to something like this. And from here, you can, once you have selected all the different elements of your request, you'll get to decide what parameters, what steps you want, and you will be able to view the Mars request. So this is a good way to start your Mars request. I would not recommend starting a Mars request from scratch. I would always go to the Mars catalog, get the scaffolding for your Mars request, and then you can adapt it later. In this case, I just copied the request, and I'm going to write it to a file called real.rec. And I'm going to add a few bits and pieces essentially for post-processing. In this case, I'm interested in not a global field, but just a cropping over Europe. And I want the data to be on the 1 degree by 1 degree regular lat long grid. So I'm going to create that file, which is here. You can also write it directly, but it was more convenient to do it through the notebook itself. And we can instruct Mars to run the request itself. So the request has completed. I downloaded 4 fields, and here I can see those fields on my real grip file. Another cool thing that you can do with the grip tools from the command line is to use the geography namespace And as you can see here, I didn't get the global fields. I got some partial fields over Europe. You've got here the latitude and longitude points of the bounding box, and the description of the grid itself. Now, if you want to see how Mars performs here, I'm going to run a bigger request here, getting some ensemble data. It's going to retrieve a few gigabytes of data. Of course, I need to write the request first. So this is going to be retrieving around 3 gigabytes of data from the field database, because it's real-time data, because I'm requesting well, it's recent data because I'm requesting data from yesterday. This should go directly from the Atos FDB. So here it is. I got my 3 gigabytes back, as you can see here, and my big dot grip. I won't list the contents of that grip because it's 250 fields. But you can see how quickly then you can get hold of your data if you're running on the cloud. Now on to a different service. In this case, the CDS, the Copernicus Climate Data Store. We are going to do the similar thing, but this time getting the information on the data from the Climate Data Store. You have here all the links to the Climate Data Store itself, and the Climate Change Service page. The ADS, the Atmospheric Data Store, is very similar, so I won't cover it today, but it's same setup and same idea. To access the CDS, you need to have a CDS API key. So you need to self-register on the page, log in, and then go to the to this how to use the CDS API, and you will copy those credentials here into a file called CDS APIRC in your .cds APIRC on your home. I've already done that, so I'm not doing it. And you will need to install the CDS API, which we don't need to because it's part of our environment already. And once you have those little tools, you can then from Python start using it, importing it, and then using this client to define your request. In this case, you can define things like the time series here that I want, the area that I want, and in this case, I'm also getting the data on netcdf format. So I'm going to do this. Let's see how long it takes. But essentially, this will be accessing the CDS, trying to get all this information from the reanalysis 05 land dataset. I'm going to get some temperature and some wind information. And then once it's done, I will see here that the request is complete. You might be queuing because this is a very popular service. And once it's there, you can then, in this case, because it's netcdf, you can use standard netcdf tools from Python to open the data set and manipulate and see how it looks. So the data is there now. And then if I run this, I can see that I've downloaded that netcdf, and here you have the different variables inside the netcdf. Right, how are we doing? So we'll need to speed things up a bit. Last two playbooks are more of an end-to-end process. In this case, using MetView to extract some wind components from Mars, or read them locally if you have them locally, and then do some computation. In this case, computing the wind speed, and then doing some plots. So let's import MetView first, and let's try and retrieve the data from Mars. As you can see from MetView, you can directly retrieve data without executing Mars explicitly. The result is a so-called file set which I can describe. As you can see, the two components on different levels, on different steps. And what we're going to do is to select the UMV components at the 500 level and compute the wind speed with the MetView function. And the new field, this SP, will contain the wind speed in this case, but the metadata will be wrong. As you can see here, it's still saying that it's the U component because it basically inherits the metadata from the first field. So we're going to be changing that metadata and setting it to wind speed. As you can see now, we have changed, and then we can plot that data directly here with MetView. If you have IPy widgets installed in your Jupyter, you'll be able to have this more interactive plot, and then you can play if you need to. And if you want to do the same with the EarthKit, the new package that we have developed at ECMWF, you can do a very similar thing. So essentially, we are doing the same idea here. To get hold of the data. In this case, we're reading it from file, but we can also read it from mass. If I delete this file and rerun the cell, you can see that EarthKit is executing mass in the backend and getting the data. You can also use EarthKit to get it from CDS directly if you want to. So here's another example how you could get similar data from the CDS. And the rest is very similar to what I showed you earlier. As you can see, you can also select those fields, the UMV at 500, to then compute the wind speed. And in this case, we're not going to be using any custom functions. We are going to use to leverage the native NumPy infrastructure in Python to compute that wind speed and to make sure that the metadata is well set in our new field of wind speed, as you can see. And we can also have a similar plot just for the first one, for this first field. Or if you want an interactive plot, you would need to do the widgets yourself. At the moment, EarthKit doesn't integrate those in the plotting yet, but you can do a very similar plot like the one we saw earlier with animation and so on. So that's more or less the demo. If we go back to this one, we can just summarize what we did today. So we tried to go from Jupyter to Mars. We created an instance in Morpheus, automated the deployment of the application, in this case, the Jupyter with Ansible and Git, and put it all together. So that bit was more or less wearing the more the IT hat. So hopefully that gives you an idea of how you can use automation and integration with Morpheus to really deploy your applications, not only Jupyter. And then on the other hand, we also have worn the more scientific data hat, and we use Jupyter as an interface for that data analysis. We saw how to configure the data services, Mars, CDS, to access those from the cloud, and we showed very quickly how to use some of the tools that we put at your disposal to access and manipulate those data. And that's it from me. And then I'm happy now to take any questions. I don't know if there's any in the chat. I haven't been monitoring the chat.
Hello, okay. Can we ask questions by voice?
Yeah, of course. Yeah, go ahead.
So, well, first, thanks. It's really useful to see how you can set up everything so quickly. So now there's quite a lot of work to go and see what is inside those playbooks, because when we need to customize stuff, we need to actually check what you have done and learn about all the tools and so on. I have a quick question. How did you install the Jupyter Lab? Is it from, so it's a conda install with a systemd script somewhere because you just activate the service. And so how much did you add to the base Jupyter package to make this run?
Yeah, so basically, if we go back to the notebooks, not the notebook, sorry, the Ansible, there are two aspects to it. If we go to the Jupyter role, by the way, as I mentioned, this repo is public, so you can I can copy the URL here, and you can go and browse yourself if you want to. But the idea is mainly two things. One is through my conda environment here, I am basically doing this, so making sure I have Python, Jupyter Hub, and Jupyter Lab installed as part of my conda environment. Yes, this is just the extra Git plugin, so I can clone easily from Jupyter itself. And the other aspect, if we go to the tasks themselves, as you can see, the only thing I'm doing here is to install the environment that I defined, Jupyter, and all the other dependencies that I need, all self-contained in one single conda environment. And lastly, what I do is to create a systemd service for Jupyter Hub, so that then I can make sure that service is run as a system service, and it's going to be up when I reboot the machine and so on. This is this service systemd unit, so basically running the Jupyter Hub command.
Okay, and running as root, so that you don't have to mess with permissions.
Exactly, but just for simplicity in this case, you can of course make it a bit more fancy and have a dedicated user and manage the permissions so that this can be done. But in the end, you have to run on port 44380, so you need to have some privileges to do that. So that's why, for simplicity, I'm using the root user. But this is the Jupyter Hub. When you log in, by default, I'm using I didn't go into those details, but I'm using the default PAM authenticator in Jupyter, which will basically leverage the actual users in the machine. So when you log in as my own user, Jupyter Hub running as root will create a Jupyter Lab instance for my user, running as my user, not as root. Yeah.
Okay.
I hope that kind of summarizes the.
Yeah, thanks. Just adding some very quick comment. Service Jupyter. Okay, no, because I did something very similar, and it was quite well. Yes, with the PAM authenticator, and I'm on the method side, so I have LDAP, and so I can just add users in the LDAP, and that works fine. So if others are interested.
Of course, yeah. I mean, there are many ways you can do things. I mean, I just picked the simplest one for the purpose of this webinar. So because otherwise it would be just too complex to go through all the details. So, but it's with the default setup, you can get something quite decent and usable.
Thank you.
Okay, so let's see if there are questions that haven't been answered. I see that Roberto has been busy answering some questions. Is there any question that hasn't been addressed? I don't think so. All of them, right?
If I may, I have extra questions.
Yeah, of course. Yeah.
One of them is quite easy. So you have external network access. So the virtual machine that you created has an IPv4 address.
Yes.
And when you create the machine, the firewall opens the 80 and 443 port to that machine, right? And SSH port.
Yeah. So for example, in this case, if I go to the network I have set up my external internet, which gives me a public IP. Yeah, and but I could have used a floating IP, so it would have worked as well.
Because my question here is whether, well, what's the limitation? Because I guess IPv4 addresses are limited on the cloud as it is everywhere. So what's the limit on that?
Yeah, so I mean, it depends how many you plan to have, but it should at least on our side we are okay in terms of numbers of IPs, public IPs. So unless you plan to have like hundreds of them, then it should be fine.
I have two for now, one for the SSH proxy that comes by default with the tenancy, and one for the Nginx proxy that's available as well as a default image. So I have two, and the plan is to use a single IP for the HTTP proxy, maybe using several host names to allow proper redirection.
So one thing you could do in that case as well, I mean, I didn't go into that complexity, but you could have also you know, a kind of a reverse proxy running on your main gateway with that public IP, and then redirecting to an internal Jupyter Hub instance. And then, you know,
actually at first I even didn't dare to ask for a second external IP machine because I don't know how much was available. But so I settled on two using reverse proxy.
I think at EMETSAT, and maybe my EMETSAT colleagues can correct me, but I think that there are some quotas in terms of floating IPs that you can use. But I think, you know, having 2 or 3 shouldn't be a problem. Yeah.
Okay, thank you.
Yes, thank you, Xavier, for confirming.
And of course, as I mentioned, if you want to expose HTTPS access to the outside, you need to make sure that you also select the right security group, so that then the firewalls in the cloud infrastructure are open or allow the HTTPS traffic into your box.
Okay.
Hi, I wrote one more question. I'm interested, maybe you said it in your talk, but why do you have or set up a Jupyter Hub in the first place? Isn't it enough to just have a Jupyter notebook running and exploring the data and downloading the data?
Yes, so I didn't go into too much detail about the difference between Jupyter Hub, Jupyter Lab, and Jupyter Notebook. Yeah, but yes, indeed, you can use Jupyter Notebook or Jupyter Lab as your interface, and forget about the hub. But then you have to manage yourself the proxy of the HTTP and all the authentication to get to the instance of Jupyter yourself. Yeah, the hub already, you know, kind of helps you doing that, because that's what it does. In general, the hub is useful if you have multiple users accessing the service. It's not the case in this example. It's just one user, but the same infrastructure can be used. And I'm leveraging what Jupyter Hub already provides out of the box to basically use all the authentication and proxying features. But yeah, certainly you can, if you want to play it a bit more difficult, you can certainly run only the Jupyter Notebook or Jupyter Lab, and then you'll have to worry about how you do the HTTPS. You might have to set up an Nginx Apache server on top, so that you can proxy all the requests, do the SSL termination, and so on. So it gets a bit more complicated, but certainly you can do that.
But why is it getting more complicated? Because the Jupyter Hub, I don't know, requires a lot of things to set up. Whereas if I just connect to a virtual machine, install my Python environment, and install my Jupyter Notebook, I'm all set up, right?
And how do you connect to that?
Where do I connect?
How do you connect? Do you expose your HTTP, because Jupyter Lab will run on the
you can use a remote desktop connection, for example.
Yeah, but then you have to connect to the machine in a different way. So what we're doing here is to basically simplifying the process from the user perspective, so that you can just use your browser to put the URL there and just start working. Yeah.
And wouldn't it be easier that you provide a service as a Jupyter Hub service instead of that everybody has to set it up on their own?
This was just an example of how you can do something in terms of automation and in terms of setting something up that is useful and usable in your own tenancy. At ECMWF, we have a Jupyter Hub service. At the moment, only with the HPC backend. We might in the future explore how to expand it to the cloud. But the problem is that if you want to have some custom things in your environment, or in terms of in terms of resources, or accessing other resources in your tenancy, you need to have something running in your tenancy. Yeah,
it's clear. I just mentioned it because scientists are typically overwhelmed by all this IT stuff, and without the background and that you know how things work and Ansible and all those things, it's not so easy for them in the beginning.
Yeah, so certainly.
Actually,
yeah.
I had some other feedback that I wanted to comment on, is that I look at this, I know a bit all the pieces that you used, and then I will look at the config files, I have some idea of all it fits together. But there's a lot of complexity still involved. I mean, I try to set up the things live, and I don't have Mars, and for Mars you need to set up an extra repository, and it's a lot of things that you need to be aware of. At least, let's say, a few people in every institution. And where I work, I think very few of us, I don't know how many, would be able to pick out the pieces apart to customize it for their needs, because at some point you cannot provide a ready-made solution at ECMWF, and what is already existing is really wonderful. And I really appreciate the Weather Cloud, the demos that you make, and the fact that we can use standard tools like Ansible. But weather institutions don't always realize that for it to become reality, there needs to be some effort from the institutions as well to bridge the gap between the scientists and the nice interface that we can have with this Jupyter Hub setup designed for our user within our tenancy.
So one thing we are working on is something called the marketplace, where what we want is to put out there, not only us, but also coming from you guys, contributions of things like this that you think that you've worked on, and you can say, well, I can share this with the community, and so others can benefit. So we can put all those bits and pieces that might be more complex, but you've already spent the time and effort to put together. So then others can also benefit from your work. Yeah. So this is something that we are working on, and then hopefully in the near future we'll be able to open it up, and then offer things like this by default. So then you can go and pick up what's interesting to you without having to really understand or know all the details of how to implement such things. But stay tuned for more info on that. Yeah, we're quietly working in the back end. And no more questions so far, I think. There was a question from Stefano, right? How to manage the users. So at the moment, as I say, for this example, we are using PAM and just using the local users that are created in the instance itself. But then you can think of about other things, like integrating with LDAP, like it's been mentioned, or integrating any other identity management system that you may think of. Yeah. So the cloud is about flexibility. There are many ways of doing things, and you can go as complex as you want, or just to suit your needs. Yeah. Okay, so I realize we are already quite a bit over time. So unless there are more questions, I think we can leave it here. The recording will be made available shortly as well. And again, the code for the webinar is public, so you can go and browse it and just take it if you want to. I try to keep it as simple as possible. So certainly there are things that can be done a lot better, but for clarity and for just the sake of just presenting it here, I tried to make it as simple as possible. And with that, I think we can leave it here. Thank you very much, all of you, for coming today. And well, see you around. You can continue the discussion if you want in the Rocket Chat general channel if you want, and then we can see each other there as well. And stay tuned, because we're gonna have more webinars coming up on different topics. So stay tuned on our announcements, and then yeah, hope to see you there in the next one.